Hello, my name is Kain, and I will be covering part 3 of our course project, which is the Jenkins GitLab integration and the corresponding CI pipeline. The objectives of this part were to use Docker and Docker Compose to deploy GitLab and Jenkins containers fully configured, and then to integrate those containers so that they could communicate with each other, and then to set up a pipeline within Jenkins to sneak scan the contents that it would pull over from GitLab, breaking the build if there were any high or critical vulnerabilities found. Then to demonstrate this pipeline using the OWASP juice shop. The development environment that we used to perform these tasks were Windows 10 and using Docker Desktop. This is what our Docker Compose file looked like for setting up and configuring GitLab and Jenkins. Similar to part 2, we had to establish a GitLab home environment variable to have a place to mount the volumes locally. And you can see in our omnibus configuration here, we established an external URL that is unique. It's not localhost or our local IP address, and that was needed because the way that we set up the container registry, it needed a unique URL. We then linked this gitlab.example.com to our local host within a host file for this to work. We have the SSL certificate and key set up for the registry, and we also have GitLab listening on port 80 so that Jenkins can communicate to GitLab. We've opened up and mapped some ports from the GitLab container to the local host. So you see there 80, 443, 22, and 5555. And then we've mounted the volumes. For Jenkins, we similarly mapped ports 8080 and 50,000. Some of the key steps for the integration were adding the GitLab plugin and configuring it in Jenkins, configuring the webhook within GitLab so that it could trigger Jenkins, and setting up the GitLab connection authentication within Jenkins with the user-specific API access token. And then within the jobs in Jenkins, we configured the webhook, the source code link, and the GitLab connection. For Sneak, we opted to use the Sneak plugin rather than the command line interface, and that allowed us to build Sneak steps right in the freestyle jobs themselves. And then we had to grab the API token from our Sneak account so that it could be authorized to perform scans. For building the pipeline, we had to start with building some jobs. So you can see the job named part 3 and the job named sneak scan below. And then we had to link those two jobs to actually form the pipeline. And then we used the view option to create a pipeline view that actually displayed this link here. In this instance, all's part 3 does is catch the trigger from GitLab, and then Sneak Scan will pull the information over, download the dependencies, so it's not just scanning the source code, and then it will perform the scan on the source code and the dependencies. To run the pipeline, we'll push to GitLab, and that'll trigger Jenkins via the webhook. And then the Jenkins pipeline will start, and that's when it'll download the content and then the dependencies, and then perform the sneak scan. Then the build will complete. Now we'll jump into a demo of the infrastructure and the pipeline. We will begin building our infrastructure from a clean install of Docker Desktop. On the left here, we can see that the containers section is completely empty, as well as the images and volumes area. In PowerShell, we will navigate to the directory where our Docker Compose file is stored, and from there we will run Docker Compose up, which will begin pulling down the GitLab and Jenkins containers, and then spinning up our fully configured containers. This will take a minute, so we will skip ahead. We can see here that Docker has successfully pulled down the images for GitLab and Jenkins and started the containers for both of them, and they are successfully running. You can see over here in Jenkins, I've logged in and created a user called Kain. And in GitLab, it's up and running, and we can create a project within GitLab. And once it generates, we can go and see that it's configured to allow for container registries. We will now upload our image to the container registry in GitLab. To do that first, we'll need to download the image into Docker Desktop. And so what we have here is Docker Desktop in the top left, displaying the current images held locally, the GitLab container registry on the right, and the PowerShell in the bottom left. We will begin by actually logging into the container registry. And then from there we will pull the container onto our local machine so that Docker can recognize it. And this will take a bit, so we will skip ahead. Okay, the pull has completed, and we can see that we now have the GShup image within Docker Desktop. The next step we'll need to do is tag the image with where we want to push it to. And to do that, we'll use Docker's image tag feature. And we can see that created this new entry within Docker Desktop Images. And we'll simply push that to the GitLab container registry. And we can see here when we refresh the container registry that the image will be present. Now we will grab the API token for this user in GitLab to give to Jenkins so that Jenkins can connect with GitLab. To do that, we'll go up to the user's profile, and on the Access Tokens tab, we can establish the token we want. We do already have the Jenkins tokens created down here, but to do that, we selected the scope for the token and gave it a name, and then created the access token. And this gave us the access token, which we will now use in Jenkins. Here is where we set our credentials within Jenkins. First on the list is for the Sneak API, where we take the token generated from our Sneak user account and put it in Jenkins so that the Sneak plugin is authenticated. The second is the GitLab API token, and the third is user credentials to GitLab so that the jobs can pull down the source code. This is our pipeline view that we have configured to run our two jobs in. As mentioned before, we chose part 3 as our starting job, and because we linked sneak scan to start on completion of part 3, that was pulled into this build pipeline as well. Now we'll take a look at what is within the part 3 job. We can see we have our GitLab connection set here. We do not need to link to source code in this case, but we do enable the GitLab trigger via the webhook. So this is the URL we used, except with our local IP address in instead of this external URL, the port, and then the project. So this will trigger when there is a push in GitLab. And that's all that this step does, is just the trigger. Now in the sneak scan project, we can see we also have the GitLab connection, but in addition we have the user credentials for the source code within GitLab, and then we have a trigger here, and instead of just the webhook trigger to GitLab, we trigger it off the completion of another project, in this case the part 3 project, and it will watch that project, and if it builds and it's stable, then the sneak scan project will commence. The first thing it will do is pull the source code in from GitLab, and then we run npm install to install any dependencies for the source code. Then we will commence with the sneak security scan. And so for that, we use the sneak plugin, which gives us this build step here. We can configure it to fail the build if any high or higher vulnerabilities are found. So that would be high or critical in this case. Here's where we use that sneak API token so that the sneak is authenticated. Here we configure our webhook in GitLab to trigger Jenkins to start the build. This requires a link to the URL of the project that we want to start with the trigger. It's important in this case for us to not use our external URL of gitlab.example.com or localhost even. This only worked when using the actual local IP address with the port 8080 on it. Then next we have the secret token generated from within the Jenkins job, and we chose this to trigger on all push events, and we disabled SSL verification. To ensure that the webhook can actually trigger Jenkins, we have to configure some network settings within GitLab, and that just allows outbound requests to go to something on the local network, and that's checking some boxes here and then adding our local IP. Now to demo the pipeline, we will start with a push to Git to trigger things off. I'm pushing just some simple change just to trigger the webhook. Okay, now that that was successful, we can go to Jenkins here, where we see that part 3 is in the queue to build. And once that's successful, we will see that sneak scan is in the queue and has started. We can take a look at the sneak scan project and see what it's doing right now in this build with the console output. And it's probably still pulling the content down from GitLab, but after that it will begin to install any dependencies for the content. So it looks like npm has actually already started installing for the dependencies here, and this will take a while, so we'll come back once the sneak scan has completed. Okay, back on the sneak scan project interface, we can see that our build 25 has just completed. And we can go take a look in the console log to see what happened, because we see that the build has failed. And if we scroll down to the bottom of the console, we can see that the sneak scan did in fact complete. So successful completion, but fail because there were vulnerabilities found that broke our threshold of high. To take a look at those vulnerabilities, we can follow the link that Sneak provides here. And we can sort through the vulnerabilities, maybe taking a look at the top 4 critical ones. And so to recap, because this sneak scan found a number of high and critical vulnerabilities, that job failed and it would break the build, preventing it from completing and pushing out a container with vulnerabilities.